let's take a look at proving some more lines parallel, but this time we're going to do it using a two-column proof. This is what we're given. We're given that R is parallel, line R is parallel to line P. So I'm going to go ahead and indicate the arrow showing which lines are parallel. These two lines are parallel. We're also given that angle 1 is congruent to angle 3. What are we trying to prove? We need to prove that, this is what we're trying to prove, that line L, which is here, is parallel to line M. Once again, we know the two lines R and P are parallel. We know angles 1 and 3 are congruent. We need to prove these two lines are parallel. Okay. Let's begin. Now, one of the first things you do is you use your given as your first statement. Well, I'm going to go ahead and write that line R is parallel to line P. And that was given. Okay? Now, if you look at the figure, you will find that you will see that, what about angles 2 and 3? Well, 2 and 3 are alternate exterior angles. And since R is parallel to P, then I can say that angle 2 is congruent to angle 3. And the reason? Alternate exterior angles theorem. Okay? All right, let's go back here. I use this given. Let's go ahead. We're also given that angle 1 is congruent to angle 3. That was given. You see anything? I see something. Look at this. You have 2 congruent to 3. You have angle 1 congruent to 3. What can you say from that? Well, if you have 2 angles congruent to the same angle, these 2 angles, angle 1 is congruent to angle 2. And the reason? Transitive property of congruency. That's what we needed to show that the lines are parallel. Because what kind of angles are 1 and 2? 1 and 2 are corresponding angles. So if we've shown right here that 1 and 2 are congruent, now we can say that line L is parallel to line M. It's the converse of the corresponding angles postulate. We've proven line L parallel to line M.